Hi Year 2s, it is Wednesday today. Welcome to your maths learning. As you can see behind me, I have some more 2D shapes. We're still learning about shapes this week, moving our thinking forwards just a little bit. Before we get started with today's session, I wonder, looking at the shapes on the board, could you see how many of these 2D shapes you are able to say the name of? If you pause the video, I'm going to go over them in just a second as well. I can see a few different shapes on the board here. Now, looking at those shapes, I can see this one here with 4 sides that are all the same length. This has 4 sides the same length and 4 vertices as well. This is a square. This shape has 3 vertices and 3 sides. It must be a triangle. Can you see another triangle on the board? Yes, the green shape here is also a triangle. It looks different to the orange one, but it still has 3 vertices and 3 sides, so we know it is a triangle. Remember, tri means 3, tri being T-R-I. This is a 4-sided shape with 4 vertices as well. Is it a square? It's not. What shape is it? Oh, it's a rectangle, of course. How do we know it's a rectangle and not a square? Well, the reason we know that it is a rectangle and not a square is because a square would have 4 sides the same length. I can see this shape has 2 long sides and 2 shorter sides as well. And we all know what this one is. That one curved side, this shape is a circle. Great job. Now, yesterday we also learnt, as well as the word vertices, referring to the corners of a shape, we learnt the word polygon. We were looking at polygons yesterday. Can you remember what type of sides polygons have? I'll give you a clue. Yes, they only have straight sides. So can you spot the odd shape on this board? Which one is not a polygon? The circle cannot be a polygon because it has the curved side. So we can say all the other shapes are polygons. This one is not. That curved side means it cannot be a polygon. Now today we're going to move our thinking on. And I'm going to ask you, is it possible for me to find some shapes on my board that have a line of symmetry? Shapes that are symmetrical. Now, you might not be sure what that word means. Maybe you already have an idea. So let me say my question in a different way. Is it possible for me to find shapes where one half overlaps the other exactly? Now, we're really lucky here because we have learnt all about fractions and we've been finding halves of shapes. So we need to find some shapes where we could show exactly one half of the shape, folding by overlapping it exactly the same. So the parts look the same, sorry. So we've already done some learning that helps us with this today. How lucky are we? Fantastic work that you were paying such great attention during our fractions learning. Now you can use it to help you with your learning about 2D shapes as well. So I'm going to model for you and show you how we can find shapes that are symmetrical, shapes that have a line of symmetry. Let's start with this triangle. Here is my triangle. If I would like to see whether or not this is symmetrical, I could try and fold it. And if both parts overlap exactly, so there's no leftovers, then I know this is a symmetrical shape. Would I fold my shape this way for both bits to look the same? No, I don't think so either. If I was to fold it like that, you can see both parts do not look the same. I'm left with a part at the bottom that's just a triangle and then a very big chunky part at the top. They would not look the same. How would you fold this triangle? Or how could I fold it? If I can't fold it from the top to the bottom, perhaps I could fold it the other way. Let's Let's give that a go. I'm going to marry up those corners, let those corners meet, and I'm going to fold the shape as neatly as I can. I am folding it in the air as well, so it's not going quite as great as it would usually. Now, here's one side of the shape. You can see it's all orange. Is it still all orange on that side? It is, isn't it? Now, if I open it out, can you see that both halves look the same as one another? Now, when I look in a mirror, if I were to look in this one, I know you're not going to be able to see my face, but when I look in the mirror, I can see my face in this mirror looks exactly the same as my face in real life. So if we were to imagine this line was a mirror, we are saying that this side of the triangle is seeing the same as this one. They both look the same. Now, this shape did fold in half exactly. Nothing was overlapping. It was the same shape and size on both sides. So where I folded along folded the triangle, I could now draw a line along there. I'm going to draw that in. Now, this line would be called the line of symmetry. And that means if we fold the shape along that line, it would show us a mirror image on both sides. So we found that actually a triangle, or this triangle particularly, is symmetrical. We can fold it exactly in half and it will look identical on both sides. Great. Sometimes we'll have a shape, let's start with this one. This is also a triangle. Now, we've just folded a triangle and found that it is symmetrical. It did have a line of symmetry. So surely this one will too, but we're not going to guess. Let's have a go at folding it. I can usually fold from along, the middle, top to bottom, or across from left to right. We can have a vertical line of symmetry or a horizontal line of symmetry. Here we had a vertical line of symmetry, top to bottom. I don't think if I fold it horizontally with my fold line across from left to right, I don't think that's going to make a line of symmetry. I think, like the other triangle, I need to fold a vertical line. I'm going to give that a go. We'll see how it works. So I'm going to try and fold through that middle point on the triangle. And as I do, I'm going to show you what I've got. There's one side of my triangle. It's super neat and flush. Now, if I turn it around, can you see there's a lot of leftovers here? Would that be a line of symmetry? Do both parts look exactly the same, or are they now not the same? Well, we couldn't say that this was a fraction because they're now not equal. So we cannot say that it has a line of symmetry either. So if I were to draw a line down here, we can see that actually both sides are not the same. I will show that for you now. Let me draw that line in where we've just folded. Now, if I have a look, I can see, I don't know about you, but this does not look the same as that one. If they were looking in the mirror, this one has a little bit more at the bottom here than this half does. So we can say that this triangle actually is not symmetrical. We cannot fold it so that it looks exactly the same on both sides. Let's pop that one back up. That one does not have a line of symmetry. It is not a symmetrical shape. Sometimes we'll have a shape like a square. Now this shape, we could fold it one way. And I know we can find half of a square because we've been using fractions for the last few weeks and you have all been folding your squares into two parts. There is my line of symmetry. I've folded a vertical line from top to bottom. Has a vertical line of symmetry because both halves look exactly the same. So I can draw in that line of symmetry. But I could have also folded it the other way. So it has one line of symmetry, but now when I fold it the other way, I can see that actually it has a second line of symmetry. So I could have folded it this way. There are my equal parts. They're both the same and identical. I could have folded it this way. This half looks the same as this half. They are identical. I could have folded it on the diagonals. I could have folded it that way also. Now I know that both halves would then look the same. Quite hard for me to draw my lines without my big enough ruler. Miss Pope really wasn't as prepared as she could have been this morning. So I've also drawn my diagonal lines. I could have had a diagonal this way and a diagonal that way. So this square, unlike the triangle, which had just one line of symmetry here, this one has 1, 2, 3, 4 lines of symmetry. If I were to fold my shape on any of those lines, both parts would be a mirror image of one another. So shapes can have more than one line of symmetry. So remember, when we're talking about symmetry, we're asking, can you fold that shape in half exactly so that both sides look identical to one another, as if they were looking in a mirror? If the answer is yes, the shape is symmetrical. If the answer to that is no, the shape is not symmetrical, like this one. So we could check both of these two shapes by then folding them in half and seeing whether or not they are equal in both sides. Are they a mirror image of one another? Sometimes we'll have shapes where there isn't a line of symmetry, again like this one, and we can sometimes guess whether or not they're going to be symmetrical. If I were to draw my line down through the middle, I can see if I were to fold along this line, I know that these parts are not going to be equal. Look, there's a bit popping out down the bottom. And again, if I was to draw my line from top to bottom, I can see that if I were to fold it, I can see again, they really wouldn't match up. This shape would not be symmetrical either. So today we are trying to learn all about lines of symmetry and symmetrical shapes. We would like you to be able to identify lines of symmetry in 2D shapes. So that means showing me where you would need to fold the shape to show two halves that would look exactly the same as one another, a mirror image to each other. They would overlap exactly with no bits left over. So the line we draw on the fold is called the line of symmetry. If we can draw the line of symmetry, a shape is symmetrical. So here is our guided practice for today. And we would like to know whether or not each polygon has a line of symmetry. These are our polygons. They are shapes with only straight sides. Remember, I said usually your line of symmetry would go down or across. And then sometimes your lines of symmetry may be diagonals. But I would always suggest you start with my blue lines going down and across, vertical and horizontal. So let's start with this one. This shape has 5 sides and 5 vertices. This is called a pentagon. Let's go down the middle. Now, in fact, I'm going to use a straighter line than that. That really isn't helpful, Miss Pope. Now, if I were to draw a line down the middle of this shape, I can see that actually this part of the shape looks like a mirror image of this one. So I could give it a tick and say, yes, this one does have a line of symmetry. I could then do the same on my next shape. I'm going to draw a line down here. Oh, look, they do look like they're looking in a mirror. This does look like a mirror image of this side. If I were to fold that shape along my vertical line, I believe they would look the same. I actually think if I were to fold it this way, they would also look the same. So this one does have a line of symmetry, or at least one, so I'm going to put a tick in there. Now looking at this last shape here, I really don't think if I was to draw a vertical line here that these two parts would look the same. And I don't think it works if I go this way either. So I'm going to say, no, this polygon does not have a line of symmetry. We can do the same even with non-polygons. Draw my line down the middle of this semicircle, and I can see that both of those parts look like a mirror image of one another. I can say they are symmetrical. Likewise, this shape here, which is a non-polygon, it doesn't have all sides that are straight. If I go through the middle here with my vertical line, they do look like a mirror image of one another. If I was to fold along that line, there would be no overlapping parts out of place. So I can tick and say, yes, this does have a line of symmetry. So I would suggest that when you're doing your work today, you draw your vertical line first. Remember, verticals top to bottom. Try and use a ruler or something straight to draw a line and to draw along, sorry, whilst you do this, just so you can see it really accurately. Then look and think, if I were to fold on that line, would both parts overlap? Exactly the same. You could also print the sheet today, cut out the shapes and have a go at folding them. That's also another way you could do this. So here is your worksheet today. You're going to see if you can find at least one line of symmetry on these shapes. If you can draw one of those lines and they will overlap exactly the same, we can say yes or yes that it is symmetrical. If we cannot draw one of those lines, we would have to put no in the box. I would expect everyone to be able to have a go at this worksheet page in today's lesson. Then many of you may get onto this one, and you've got to look at the line that has been drawn, the line of symmetry that's been drawn by somebody else, and you have to say whether or not you agree with them. If you were to fold along that line, would both parts look exactly the same? Would they overlap exactly the same? Yes or no? So that's your worksheet for today. Have a go, try your best. Like I said, you may want to cut some of these shapes out and fold along the lines or fold them through the center and see whether or not they have a line of symmetry. A line of symmetry is the place where we can fold a shape so that it looks exactly the same on both parts. If it has that line of symmetry, we can say the shape is symmetrical. So that's today's learning. Head over now and have a go at your worksheet, and then we'll see you again tomorrow where we will continue looking at symmetry. So don't worry if it doesn't quite make sense today. Give it your best shot, and then we'll try again tomorrow and build on what we know today. Take care, Year 2. See you soon.